Today, we'll be looking at radical substitution reactions. It is one of the common types of reaction in organic chemistry that you will learn in IB. Substitution is a replacement of atom or group of atoms in an organic molecule with another atom or group of atoms. Alkanes are relatively inert due to strength of carbon to carbon or carbon to hydrogen bonds. In addition, these bonds in alkanes are nonpolar, which makes them unreactive towards polar reagents. To transform alkanes into more reactive species, some of the nonpolar bonds must be replaced with polar bonds. One way of achieving this is to halogenate with the alkane using radical substitution reactions. For example, with radical substitution reaction, this ethane will react with Cl2 gas under UV light or heat to form chloroethane and HCl. Now, there are three steps involved in these radical substitution reactions: initiation, propagation, and termination. Out of the three steps, we will first look at initiation. Initiation stage involves with homolytic fission of a molecule to produce a radical species, such as chlorine. In the presence of UV light, the chlorine molecule splits homolytically, which means equally, producing two identical chlorine radicals. Like this. Now this is different to ions because the electrons are split equally from the bond. Now it is important to remember for IB that these arrows only have one-sided head like this because it represents one electrons each for each element. It is important to remember for the future IB questions. Now let's move on to step 2, propagation step. This propagation step includes reactions of radical species with non-radical species to form a different pair of non-radical species and radical species. Now it sounds very confusing, so let's show an example. In this case, the first propagation step occurs between an ethane molecule and a chlorine radical. Well, let's represent the lone pairs like this. This step, this hydrogen sticks to chlorine, making ethyl radical, like this. This allows the reactions to continue or, in other words, propagate. Radical substitution is therefore a chain reaction, as reactions in the propagation step produce further reactive radicals like this here. This ethyl radical reacts with another chlorine molecule, producing the desired halogen alkane, chloroalkane. Like this. And this will produce another chlorine radical. The regenerated chloride radical can take part again in the first propagation step. This cycle of the two propagation steps will continue until termination step occurs, and this goes the same for every other radical substitution reaction. Lastly is the termination step. The termination step includes reactions between the two radical species to form a non-radical species, so quite opposite or quite different to the propagation step. The termination step therefore reduces the concentration of radicals in the reaction mixture until the reaction is finished. You can see from the propagation steps that these radicals need a constant supplies of radicals to continue, like the CLs. Therefore, termination reactions slow down the reaction, eventually stopping it completely. Some examples of termination reactions are Cl radicals joining to form chlorine, ethyl radical and Cl radicals join to form chloroethane, and Cl radicals and hydrogen radicals. And two ethane radicals joining to form butane. As a result of these reactions, a mixture of products is formed, including the desired product, chloroethane, but also chlorine or maybe hydrogen chloride, which can be recycled for the initiation step. Butane can also be produced, which is a byproduct. Chloroethane has carbon-chlorine bond, which is polar. Therefore, an organic molecule with greater reactivity has been generated, which can be used in other organic chemistry reactions. In the same way, any other alkane can be halogenated by chlorine or bromine in the presence of UV light or heat through radical substitution reaction. Fluorine, however, is too reactive, so direct fluorination of alkanes often leads to breaking of carbon-to-carbon bonds and the formation of complex mixture products. However, in contrast, the reactivity of iodine is too low, so radical iodination of alkenes does not occur. That is it for the radical substitution reaction for today, and see you in the next video.